The sun is extremely far away. It's roughly 400 times the distance of the moon. And it's also extremely hot. The visible surface of the sun, which we call the photosphere, is about 6,000 degrees. So with the distance and the extreme environment near the sun, we've never sent a spacecraft to study the sun in situ, at the site of the sun. Now we will actually in 2018. In that year, a spacecraft called the Solar Probe Plus will swing past Venus, and the gravity of Venus will fling it very close to the sun. In fact, the mission plan calls for 7 passes past the planet Venus, getting closer and closer to the sun each time. But that's in 2018. Until then, we study the sun from a distance, and we study the sun with light. Visible light, ultraviolet light, infrared light, X-ray light, it's all light. And to understand the sun, we need to understand the properties of light. Light's all around you, but have you ever stopped to wonder, what is light? How does it work? We'll explain all that with an eye toward using the properties of light to see what they tell us about the source of the light, and that's the way we'll learn the properties of the sun from a great distance. Light is like nothing you've ever seen. No, really, I mean that. That's because all the light that you ever have seen comes from atoms, from the motion of electrons in atoms, and the atomic world, the world of the very small, the quantum world as we call it, has rules of behavior that are strange and very different from what you see in everyday life. So let's take a look at light. Let's try and understand and explain its properties, and then let's take what we've learned about light and use it to analyze the light from the sun. We'll find out what the sun is made of, the sun's temperature, that it has very strong magnetic fields that govern the behavior of the sun's gases and sometimes blast them violently out into space, and those particles travel through space and hit the Earth. And we'll learn all of that from studying light.